All right, let's look at the homework 11.2, problem number 10. All right, so let's solve this initial value problem. So we want to solve for y, and it goes through the point 8, 4. All right, so let's do that. All right, so this is the differential equation, and the first thing I would do is I'm going to move 4 on this side and move y on this side. So we're going to multiply through by 4 and divide through by y. So we get something like this. All right. Then we can integrate both sides. So let's go ahead and do that. So I'm going to integrate both sides of the equation with respect to x. And you can see that we can cancel x here and x here. So I'm going to actually go ahead and erase that guy. So you have dx on top and dx on the bottom are canceled out. So you are just left with just dy. All right. So that looks cleaner. All right, so antiderivative of 4 over y would be 4 times natural log of absolute value of y, and antiderivative of 3 over x would be 3 natural log of absolute value of x. So you get something like that. All right, and we can, using log property, we can move 4 up here as a power. So I'm going to actually go ahead and do that. So this is going to be raised to the 4th power. So we can do that. And also, since this is an even power, we don't really need the absolute value sign. So I'm going to just remove the absolute value sign like that. Right? Right, and I can also move 3 up here. So I'm going to go ahead and do that. So 3 in front of the natural log can be placed up here. All right, then you have some constant C1. All right, so we want to isolate y, so I'm going to raise e to both sides of the equation. Then you're going to get something like this. So if you raise e to natural log of y to the 4th, you're going to get simply y to the 4th. And you have e to the c1 shows up right here. And e to the natural log of absolute value of x cubed is going to be just the absolute value of x cubed. And e to the natural log cancel out. So we have this. All right. Then next thing I want to do is I don't like to have absolute value sign. I'm going to incorporate, if it's a negative sign, and I'm going to let this guy absorb. So I'm going to actually write it as remove the absolute value sign, but I'm going to put the plus or minus in front. All right, so that way I don't have to worry about the absolute value sign. All right, then here you have such a complicated expression for just a number. So instead of using a plus or minus e to the c1, I'm going to just write it as c. So I'm going to just write it as is equal to c x cubed. Right? We have that. All right. Then once you've done that, I'm going to plug in the value. I forgot the value was. So this goes through the point 8, 4, which means that when x is 8, y equals 4. So let's use that. So plug in 8 here, 4 here, and plug in 8 there. We're going to get this equation right here. So we know that 4 to the 4th power is equal to c times 8 cubed. We don't really, maybe I'll put the parenthesis there. It looks a little bit more consistent. All right. Then if you divide through by 8 cubed from both sides, then you're going to get the c value. So c value is going to be 4 to the 4th power over 8 cubed, right? So we get that, and which is simplified to be 1/2, right? So c is 1/2. So therefore, we have equation. So here's a x to the 4th, and the c came out to be 1/2, x cubed. So we're going to get the equation. X to the fourth is equal to x cubed over 2. All right, so let's type this equation in. So we get y to the fourth is equal to x cubed over 2. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, and then we want to find the graph of the equation. All right, so one thing you have to notice is that since here y to the fourth power is non-negative, it's never negative, so x cannot be negative, which means that the graph is going to be always on the right side of the y-axis. And you can see that the first one isn't the right one. And the second one isn't it because you have a picture on the left-hand side. All right, third picture. If you look at this third one, this looks promising, and it cannot be the fourth one. All right, so there's only one feasible one, so this is going to be the correct picture. All right, let's check the answer. All right, I came back and looks like we got this one correctly as well. All right, that's it. I hope that this was clear.